Hey kids, welcome to Objective 31. We are going to continue solving one-step equations, only this time we are going to use multiplication and division. When you look at your notes, you'll notice that it looks very similar to Objective 30 notes, which was solving one-step equations using addition and subtraction. The reason why it looks so similar is because the process is very similar. It's basically doing the same thing we've done before by isolating the variable using inverse operations, only with different operations, but they still undo each other. Before we jump in, though, this is just the highlights of our normal lesson. It won't be the best video in the whole entire world, and it won't be what the best math teacher in the world would have done or said, but we do our best, and this is to help kids who have been absent to be able to practice from home and maybe get some homework help too if they need it. Okay, so we've been talking about opposite operations, the ones that we say undo each other. For example, addition is opposite of subtraction. For example, if the bank made an error in my favor, will never happen, but if they gave me an additional $50, they would make that error right again by subtracting $50. And so addition and subtraction are opposites. Similarly with multiplication and division, if you imagine, say, a recipe for a casserole that your family really likes, you can divide that casserole recipe into smaller portions to feed just a small group of people, or you can multiply that recipe by a number to feed a larger number of people. But regardless if it's the original, the smaller, or the bigger size, they should all taste the same. So multiplication and division undo each other in the sense where you can take a big recipe and bring it down. So today we are going to use inverse operations to find the solution to an equation. This is the equation here that we are going to look at. 4x is 24, or we could say 4 times what number equals 24. If you think about it, you can probably figure out without doing any math at all that it's 4 times 6 that gives us 24. We are using this very simple question to learn these rules with so that when you do more difficult ones, you're prepared to solve them. So please follow along, show your work, because that will benefit you in knowing how to do your work in other situations. So we are going to use inverse operations to isolate the variable. We want to get this x by itself. Right now, it's in a multiplication relationship with between 4 and x. It just says 4x, no sign in between, so that is implied multiplication. This is 4 times x. The reverse of multiplication is division, so division undoes multiplication. And we can divide by the coefficient that we're trying to get rid of, 4. And because an equation is like a teeter-totter that we have to keep balanced, what I do on one side, I have to do to the other. Now 4 over 4, if you think of the fraction, is the same thing as the number 1. 4 divided by 4 is 1. So we cross this out to show that these cancel out. It's not like those numbers go away completely, it's that they equal 1. And we're trying to find the value of a singular x, 1x. And then on the other side, 24 over 4 is 6, which is the number that we predicted from the start. Now, part of the process is to check our work, and it would be a good habit for you to be checking your work as part of the process from the start. You can do this by subbing into the original equation, like so. If we have the original equation, 4x equals 24, if we say the value of x is 6, so I'm putting in 6 for this x, and keeping everything else the same, this should balance out if I'm correct. 4 times 6 is 24, and 24 is the same as 24. This is a balanced equation. So I can be sure that my solution really is 6. So that's the point where I go back and I circle my solution. All right, great. That is an example of a where we use division to solve our equation. Let's try a different one. Here I have x over 5, and it looks like a fraction. This is a reminder that a fraction is also division. This Not only is x over 5, but it means x divided by 5. So there's a division relationship there. And the opposite of division is multiplication. And so I'm going to draw in some numbers. Just watch here because I want it to make sense to you. This is a singular x in the numerator. So you could also say that this is 1/5 of an x. You can get this x by itself by multiplying by the reciprocal, which is something you may remember from long, long ago. The reason why this works is 5 times 1 is 5x. 1 times 5 is 5. And there is our 5 over 5 to get a singular x value. Another way to think of this is 1 over 1 cancel out, 5 over 5 cancels out. So whichever way that makes sense for you, go on ahead and do that. And if I multiply one side by 5, then I have to multiply the other side by 5. And I could write 5 over 1, but I don't really need to. 5 over 1 is the same as 5. 7 times 5 is 35. X has a value of 35. So again, we used inverse operations to isolate the variable. And we can go back to the original equation and use parentheses, I missed that before, to show what number we have substituted in. So we did have the equation x over 5 equals 7. Well, we're saying now that x has a value of, I'm just going to write it right over the top, of 35. Is it true that 35 over 5 is 7? Yes, it is. 35 divided by 5 is 7. 7 is 7. So this is a balanced equation, so I can be sure that my solution of x equals 35 is correct. Okay. Great. Throughout the rest of the examples, I am going to trust that you will periodically pause, do what you can, go back, hit the play button, see how you did. Also stop every so often to make sure that you understand what is going on. If you need to go back, hit the back button and maybe consider rewatching. That said, I'm going to plug through these questions, trusting that you are going to gauge your own learning speed, just so that this video is not a million years long. Okay? All right, so again, feel free to pause, do what you can, hit play, and then we'll see if we can figure these out. Okay, so here, x is what we are trying to isolate. Sometimes students have a hard time determining if they should move the 10 or the 110. I advise that you draw an arrow to the variable and then cover up the whole other side of the equation. What is left, the 10, is what you're trying to get rid of because we're trying to isolate the x. These have a multiplication relationship. The opposite of multiplication is division. What I do on one side, I do to the other. 10 over 10 is 1. They cancel out. 1x equals 11. 110 divided by 10 is 11. And I can go back and check my work. If 10x is 110 and x equals 11, 10 11s, 10 times 11 is 110. Yeah, it balances out. So please make sure that going back and checking your solution is part of the process. Okay, in this next equation, we want x by itself, and we are going to move the 12 because the 12 is what is with the x. That's what we need to eliminate so we can isolate the variable. These are in a multiplication relationship because they're shoved together with no sign in between. Opposite of multiplication is division. Trying to get rid of the 12, what I do on one side, I do to the other. 12 over 12 is 1. A singular x has the value of negative over a positive is a negative. 24 over 12 is 2. And we can go back and check our work. If x has a value of negative 2 and I have 12 of them, 12 negative 2's is negative 24. My solution is correct. Okay. As we go, I strongly recommend that you show your steps in the same way, not because I am controlling over that sort of thing, but I do know what we are going to be doing in the future, and these steps build on each other. And so it would be, helpful for you to use these same steps. My cat, Mina, you've got to move. You can see this here. Hey, say hi. And you can also see my lunch, I suppose, that I was packing. Sorry, overshare. Anyway, Stop hunting for snacks, silly cat. Okay, so here again, here is our variable that we are trying to get alone. You can cover it up, so I'm trying to eliminate the -2. The -2 is in a multiplication relationship with the x, and the reverse of multiplication is division. If I divide one side by -2, then I have to divide the other side by -2. -2 over -2 is 1, so I have a singular x now on the right side. X over -2 is -9. Now this value may be correct, but the best form to write it is variable comes first. And we can check our work. If I have -2 x's and x is worth -9, -2 times -9 is a positive 18. So we are sure that our solution is correct. Okay, one more on this side. X is joined up with a 3 in multiplication. The reverse of a multiplication is division. If I divide one side by 3, I have to divide the other side by 3. 21 over 3 is 7. So 7 is x. And again, what should I do to make this final? X equals 7. And before I flip the page, what should I do with my solution? Okay, check it out. If I have 3 x's, each of which is worth 7, 3 times 7 is 21. So I can be confident in my answer. Great, let's flip this over and keep stepping it up. So for these examples, we have our variable over another number. Now these are all fractions, but a fraction also means division. And so what this means is x divided by 3 equals 4. And the reverse of division is, multiplication. So remember we proved that this is the same as 1/3 x, and the reciprocal of 1/3 is 3 over 1, or the flip of 1/3 is 3 over 1. Because 3 over 3 cancel out, 1 over 1 cancels out, or 3 times 1 is 3, 1 times 3 is 3, 3 over 3 is just 1, right? So we can bring down our x. If I multiply one side by 3, then I multiply the other side by 3. 4 times 3 is, 12. Is it true that 12 over 3 is 4? Yes, it is. So that is my solution. Okay. For the next one, this time x is being divided by 7. The reverse of division is multiplication. What I do on one side, I do to the other. These cancel out because 7 over 7 creates 1. 4 times 7 is 28. Is it true that 28 over 7 is 4? Yes, it is. And so we know our answer is complete. Now we have the variable on the right side. Again, if you're having trouble to determine what you should do, find the variable, draw your attention to it, cover the other side of the equation. The numbers that you see are the ones that you're trying to get rid of. So this is the 8. X is being divided by 8. The reverse of division is multiplication. What I do on one side, I do to the other. So 8 times -5 is -40 equals x. And remember, go back, flip it so that the variable comes first. -40 over 8 is -5. So we're good. And finally, this one is just a little bit different, and there's a couple ways that you could approach it. Now, this time, -x is being divided by 10. The opposite of division is multiplication. What I do on one side, I do to the other. These would cancel out. 10 times 3 is 30. But when I bring down my x, I have to remember that that x was negative to start with. So this negative also comes down. And so, first of all, let's flip it. -x is 30. And remember, when you have a negative variable for a solution, you can make it positive, but then you have to flip the sign on the other side, because in essence, we're multiplying by a negative, or -1. So 30, flip the sign, becomes -30, and that is one way to solve this. Another way that you can do this, if you have the original equation, I'll rewrite it. 3 equals -x over 10. If you notice that there is a negative with the variable, you can save yourself a step by multiplying each side by a -10 instead. What I do on one side, I do to the other. So what that does is the negative times the negative create a positive. 10 over 10 cancel out. So when I bring down my variable, I'm only bringing down the positive x. It's been canceled out by the negative 10. And now negative 10 times 3 is negative 30. Flip it so the variable comes first, and so that'll save you a step of work if you notice that, if you care to do it. Is it true that a negative 30, which is 30 over 10 is 3? Yes, it is. So we can be sure that our answer is correct. Great. Let's step it up another step. For these questions, it's a little confusing because it's like we have dividing and multiplication in one, if you think about it. 2/3 comes right up to the x, so that implies multiplication. This means 2/3 times x. But the fraction 2/3 is also division. 2 divided by 3 times x. Well, what do we do? Similar to the previous row, we are going to multiply by the reciprocal again. And what that accomplishes is if I multiply across the top, 3 times 2 is 6, 2 times 3 is 6, 6 over 6 is 1, then I can solve for my singular x. Another way that you can think of it is 2 over 2 cancel out to make 1, 3 over 3 is 1, so they cancel out as well. And remember, what we do on one side, we have to do to the other. So if I multiply the left by 3 over 2, I have to multiply the right by 3 over 2. Now, oftentimes this is where students reach for their calculators, but you do not need to do this. Let me show you how you can accomplish this. If you just look at the numerators, 6 times 3 is 18. You can then divide by the denominator. 18 divided by 2 is 9. Okay. 1/3 of 9 is 3, so 2 of those would be 6. Yep, that's what it's supposed to be. So that's our solution. Okay, if that was a little confusing for you, try either rewatching that or follow along with me on a fresh question here. So, x is now on the right, and it is with a negative 4/5 x, or negative 4/5. The reciprocal of 4/5 is 5 over 4. And because I see that there's a negative there, I'm going to put the negative in as well. A negative and a negative create a positive. 4 times 5 is 20. 5 times 4 is 20. 4 over 4 is 1. 5 over 5 is 1. Either way you look at it, I only have now a singular x on this side. And what I do on one side, I do to the other. So 5/4 times 8. Nope, that's a 4. Sorry. 5 times 8 is 40. 40 divided by 4 is 10. X equals 10. Well, a 1/5 of x is 2. 4 of them would be 8. But this is negative, so something went wrong here because, see how I multiplied this side by a negative? That sign is there because they canceled out. I should have also multiplied this side by a negative to get a negative 10. And so this is why you go back and check your work, because sometimes those signs get lost. Even if you've been doing this for 15 years, it's always good to go back and check your work. Okay, here we go. 1/3 of what number is 6? Do you know that without doing any math? Multiply by the reciprocal. The reciprocal of 1/3 is 3 over 1, or just 3, however you like to do it.